Welcome to qnawire.
Okay, so let's consider that we've got CO2, H2O, NH3, NO2, and HF. Now, I don't know about you. We could do some math and look at electronegativities and find out which has the greatest ionic character, but I think the easiest way to go about this is to just consider the top row of the periodic table. All right, so we've got, or the top two rows, let's say. We've got hydrogen, and then way over here we've got helium, right? Then we've got lithium, we've got beryllium. Somewhere around here we get, boron, carbon, nitrogen, oxygen, fluorine, and then neon. Okay. Right. And then there's stuff below this. Doesn't really matter because, hey, look, everything we've got is in these top two rows, right? And we know that as far as electronegativity goes, discounting our halogens, that the most electronegative things we have are in the top right. Right, so fluorine here is the most electronegative, and the things to the left here are less electronegative. So really, if we want to find the most ionic character, we're just trying to find the biggest gap between their position on the periodic table, right? So I mean, like, okay, well, we've got carbon and oxygen, that's an okay gap, you know. Nitrogen and hydrogen, that's an okay gap. Nitrogen and oxygen, that's not as much of a gap as carbon and oxygen was, right? But the biggest gap we've got here is hydrogen and fluorine, right? That's the most electronegative, the most difference between being electropositive and electronegative is hydrogen and fluorine. That's our answer. This is the most ionic.